Today, we're going to decode a core paradox of AI interaction, and that's why some of the most precise, powerful outputs actually come from some of the shortest inputs. Now, this is a principle that, once you really get it, it changes how you work with these systems entirely. So let's dive in.
This right here, this single sentence, is the core thesis for our entire discussion. It kind of goes against everything we know about human communication, right? We think adding more detail, more context will bring more clarity. But with AI, that very instinct is often what leads us astray. We're going to explore exactly why.
But first, it's really important to recognize that this idea isn't new, and it's definitely not unique to AI. It's a pattern you see over and over again in any system where precision is everything.
Now, what's so fascinating here is how all these fields, legal, engineering, finance, design, they all operate on the exact same underlying principle. A lawyer drafting a contract is doing the same thing as an engineer writing an API call. They're stripping away all the noise to guarantee a specific predictable outcome. In these high-stakes worlds, clarity under constraint isn't just a nice-to-have, it determines the quality of the result. And that's the same mental model we need to bring to AI prompting.
Okay, so if that's the pattern, what's the actual system behind it inside the AI? Let's pull back the curtain and look at the three core mechanics that make this work. The first mechanic is something called entropy reduction. Look, the best way to think about it is this. An AI processes language in little pieces called tokens. The model doesn't get rewarded for the friendly conversational words you add. Each and every token you provide either helps narrow down the field of possible correct answers, or it just adds statistical noise, which creates confusion. Compression, then, is just the act of ruthlessly stripping away all that noise.
And this slide just illustrates the difference perfectly. The verbose prompt on the left, it's full of what we call narrative padding. I was kind of hoping, and soft qualifiers like basically. It's how we talk to people. But the compressed prompt on the right, it's pure instruction. Every single word is a direct, high-signal command. The user's goal is exactly the same in both, but the clarity is just worlds apart.
And this is the crucial takeaway. This is not just about being brief for the sake of being brief. It's about the density of meaning. The goal is for every single token, every word, to serve a purpose, to add a necessary constraint that guides the model exactly where you need it to go.
The second mechanic is what we can call latent alignment. You see, AI models work by mapping your words to these incredibly complex internal patterns they've learned from looking at billions of examples. When you give it a long, rambling prompt, you introduce a bunch of different, often competing ideas. This forces the model to kind of guess, to average out all the possibilities, which almost always waters down the final result.
Just look at this first prompt here. It's riddled with contradictions. It's asking for a summary that's simple enough for a high schooler, but also wants complex formulas for a PhD. You're forcing the model to solve an ambiguity that you haven't solved yourself. Now look at the second prompt. It provides a single, unified signal. It makes a clear choice about the audience and the task. There's zero confusion.
And the final mechanic is cognitive efficiency. The best way to think about your prompt is that it's code for the model to execute. A clean, concise prompt is like optimized code. It just runs efficiently. But a noisy, verbose prompt forces the model to waste its processing power, its attention, on all these irrelevant tokens, and that dilutes its focus on the one thing you actually needed to do.
And this really gets to the core trade-off. It's so tempting to just dump our thoughts into the prompt and sort of outsource the hard thinking to the AI. But what high-performing users understand is that you get way better results when you invest your own cognitive effort up front, when you think sharper to define the problem with absolute precision before you even type a single word.
So, what happens if we ignore these mechanics? Well, there are real, tangible consequences. Let's talk about the real-world cost of all this instructional noise.
You know, failure here is rarely some big, sudden crash. It's more like a slow burn. It's an accumulation of tiny little instructional errors. It's the analyst who trusts a shallow summary, the creator who's just stuck in an endless loop of revisions, or the developer who blames the tool when the real problem is the ambiguous structure of their own input.
So how do we actually avoid all this? The edge, the real advantage, isn't about finding some secret list of magic words or templates. It's about adopting a completely different mental model. It's about thinking sharper.
This is the expert's cognitive process. Notice, the first three steps all happen before a single word of the prompt is even written. They define the one core objective. Then, they identify the non-negotiable rules.
And, this is crucial, they decide how they're going to judge the quality of the output before they even hit enter. And when they iterate, they're refining the structure, the architecture of the prompt, not just swapping out a few words here and there. This is a system, not a checklist.
To close this out, I want to leave you with 3 questions. And these aren't questions to look up answers for. They're questions to use to audit your own process.
Go back and look at the last few prompts you wrote. I mean, really look at them, word by word. Which ones are reducing ambiguity and which ones are just adding statistical noise?
Try this as a thought experiment. Force yourself to cut your next prompt in half. What's left over? That's probably the high-signal instruction you should have started with in the first place.
And finally, this is maybe the most fundamental question of all. Are you optimizing your prompt for expression, just to get out everything that's in your head? Or are you optimizing for interpretation, carefully architecting an instruction for a system to execute flawlessly? That choice, right there, is the difference between a generic result and a precise one.